Hello, my name is Sal, and so what I created in Unreal Engine 4 is my own water material by using mainly numbers and a bunch of number crunching, obviously, at only one texture map for which is for the normals, as you can see right here when it's moving right now here. So I made this material into instant material so I can have full control over it in real time, so I can make it red if I really felt like it. But I'm not going to. I'm gonna reverse that. So I'm gonna show you how to do it. So let me just have it to the regular plane. So I'm just gonna quickly let's use this as their base material for now. So what we're gonna be doing is create a new material. So right click material and m underscore water master. M is for material. So we open up by just double clicking or selecting and press enter. So we have this menu, and this is where we're going to be applying to our material. So what we're going to be doing is we're going to be having it as a surface, and then change it from blend mode opaque to translucent. So what we're going to get the effect of, it will be able to, well, it will allow us to access opacity. Then what we're gonna do is change this part. No, hold on. No, it's not this one. Pretty sure it's not this one. Volumetric non-directional to surface forward shading. What this allows us is to get the other attributes, so metallic, specular, roughness, and stuff. Finally, what we're gonna do is add tessellation, so PN triangles and the crack free. Right. So what we're gonna do, right, is we're gonna create our base color. So what we need is a free constant vector. So hold free, left click, and we'll need 3 of those. So what we're gonna do is convert this one to a parameter and call it base color. Didn't want to let me type, right? Here we're gonna call it gonna convert as well, and we're just gonna call it, I think it was edge color for this one. I think that's what I called it. So it's gonna be our edge, and this one will be our foam color. So we can control what the foam looks like, or so the foam color and what the edge color is. I'm gonna explain it. You're gonna see the effects of it later. So what we're gonna do is we're gonna call this one foam color. Right, so what we're gonna do is set this one to blue, just to show you guys what it looks like. This one's gonna be pure red, and finally purely green, just to kind of show you guys. And then we're gonna be playing about with the numbers to show you the end effect of it later on. So we have that. So what we're gonna need now is a LERP, so or its full name, linear interpolate. So hold L and left click. We'll need 2 of those. And from here, what we're going to do is we're going to connect this one to B, this one to A. So what we're going to do is get depth fade, and we'll need 2 of those. So hold that one and then Control W to duplicate. We're gonna put this one into the alpha, this one to the alpha. The red's gonna be in the A, and the base and the blue is gonna be in our base color. It'll be in the B, no, not base color. Now we need a scalar, so we need 4 scalars, so 2 per depth fade. So obviously all these numbers are default, so what we're going to do is, but we want to control them. So we need this one as our depth fade, drop, edge opacity, and we will need this one as our foam opacity. We're going to connect those, and they're by default 1, but what we're going to do is change them to a value which I used for water for the effect. So this one's going to be 0.9541. Game it, Unreal. Yeah. So that'll be that, and this will be the same as well, 0.9541. So this will be our fade distance, right? Obviously, at the end, you can play a bit with these numbers and see which effect will look better. So war edge foam 1. So what we're going to just call this is foam fade distance. This will be also be using out in conjunction with a base colors, which is connected to both of these. And what we're going to do is call this foam fade distance. And here we're going to call this whoops, wrong one. A edge foam fade distance and foam fade distance. No, distance. I cannot pronounce that. I tried. And these will be set to 100 by default. I'm pretty sure that's how it looks for my case. No, my bad. This one's gonna be by default 64.52. So edge fade distance will be 64.52. Foam edge fade distance is gonna be 48.57. Right, let's return. So yeah, we have that and that, and what we're gonna do is we're gonna assign them a category or a group. So what will happen is these will be all nicely placed, and this will be our priority 1. It's going to be priority 2, priority 3, base color, and this is going to be our base color. It's going to be our priority 4, base color. And this will be our base color, priority 5, base color, priority 5. So what we're going to do now is we're going to comment this, and we're going to call it base color. So in the future, when you're going over this code, well, these nodes, it'll be easier for you guys to see which part is which. So obviously, this is my way of kind of remembering stuff of how we look like, and yeah. So this is that. It's connected to what we need. Now we're gonna move on to creating our waves. But what we're gonna do is we're gonna save, which will allow us to save the material as we have and apply it. Because I want to show you what it looks like when we put that into our plane. Okay. So we have our material, as you can see, it's blue. Now the point. So you want to apply it. What we're going to do is just drag and drop onto our plane, and the shaders will compile. Alright, so what you can tell by the fog, our depth fade, and what we set so far is you have our green as the edge and red as our foam. So if I would drag a mesh like a cube and just stick up just slightly, just over here, as you can tell, the green acts as the edge and the red acts as the foam. So what we're gonna do now is we're gonna create an instance material so we can just change that in real time, just to save us time, right? So what I'm gonna do is base and edge, and what we're gonna do is actually before we do that, what we actually should do is apply the instance material to our plane, so we get this, right? So our m_watermaster_. for instance. So what we're going to do now is we're going to apply this. Oops, nope, we're not going to close that. God damn it. Right, gonna set the water to slightly less strong blue, like royal blue, to something a bit more nicer. About that, yeah, that works. And from here, for the edges, what we're gonna do is our foam color, which actually should be our edge color. So if you want to change that, it's gonna be our edge color. About the pale here, and then the red will act a slighter tint from the blue here. So what we're gonna do is set it to green roughly, so it has this kind of effect for tropical water. So what we can naturally do is apply it slightly lighter, and here gonna, yeah, so what we're gonna do is kind of create this kind of effect. So if you go to the cube now, you can see this effect. This is also seen not with the cube, but the cylinder. So if you look at the cylinder, it has this effect as well. So yeah, so that's that. Now let's we're gonna save our instant material, and then we're gonna go back to our non-instance material, so our master, to where we can change some things as well. And what we're gonna do now is we're going to don't mind that we're gonna apply our roughness. So what we're gonna do is we're gonna create comments, because this is not much to do here. So what we're gonna do is we're just gonna call this our roughness, so you can easily navigate over time. Roughness, and what we're gonna do is we're gonna add a scalar and call it roughness. Not roughness. Roughness. And what we're going to do now is we're going to we're going to set the value to 0.5036, create a LARP. So what we're going to do is we're going to be controlling two values at the same time, because it'll make sense down the line. And we're going to connect the LARP to our roughness. Now put that into our roughness group, and that's that. So for our specular, it's quite easy. We're gonna just get a scalar, call it specular, and we're gonna group it to specular. So now what we need is our opacity, normal, and world displacement. So what we're gonna do now is create our opacity. Our opacity is actually quite easy, all it requires is one depth fade. So we're going to get a depth fade and two scalar parameters for our opacity. So we need is, so obviously what we're going to do is call it opacity and fade distance, and we're going to group them into opacity. This will have a 2. So it'll be our opacity, will be our 1. Comment it, opacity, and connect our fade depth fade to our opacity. So what we're going to do now is set the opacity of the opacity to the same value what we did for the base color, so 0.9541, and our fade distance to 100. Afterwards, what we're going to do is we're going to create a comment and call it normal 1, because this is where we're going to do our normals. So we need, so what we'll do is we're going to have two normals connect with one another. So they're going to be blending and they'll be moving. So normal 1 is quite fairly simple, as normal 2 is, because normal 2 is basically just a direct replica. So what we need is a pattern. So U and nope. I believe it was U. Nope. No, that's for texture coordinate. Sorry. Yeah. So hold P and left click for pattern. And then we need a scalar called normal speed 1. Normal speed 1 will be a negative, same, which will be negative 0.009. Yep. And we're going to just group it into normal, and we're going to give a priority of 1, which is going to be, these two will be connected to a multiply. So we're going to do A and B right of that, like so. Then we need an add, so we just add an add there. Texture coordinate, so hold U and left click, which will be then used for a multiply. So we're going to connect it to an A. The multiply will be into a B. And then when we need that texture, so hold T, and we have that. We're going to convert it to a parameter. We're going to set the texture here to we need rock, so we need rock and detail rocky T underscore detail underscore rocky underscore N, which is found in our star contents when you start a project, and connect to the UVs. And all we need to do here is we need to create a normal 2 comment and expand that bit so we gain up space for workspace. Add a panner. Our scale will be the same as what we had for normal speed 1. So normal speed 2 and normal, and that. As I said before, make sure that this will be our priority of 1 as well. So the parameter for, and that'll be our normal 1. Normal speed 2 will be the same as speed 1, so 0.09 negative. And then we're going to do is create multiply, connect them into multiply, and then add, so hold A and left click. And what we need is to get our texture coordinate. No, I don't think we need our texture coordinate for this one, I think. Actually, we need a texture coordinate here. Then we're going to do is multiply, connect, connect our texture coordinate to A, and our normal speed to, that's not right, no, I'll be our multiply to add from where the texture coordinate is connected to, and then create another texture sample, convert it to a parameter, and call it normal set normal 2. God, this engine's really being unresponsive to me. And set that of a priority of 2. Same here. And then connect that to the add. So now what we're going to do is create a bigger comment. So we're going to comment the comments. We're going to call it the overall normal, so just normals. And then I'm going to expand it slightly here. Move these two slightly aside, because what we need is to create a scalar. Well, something which will connect with UV scalar. So what we can do is apply scaling to both of them, so we don't look too pixelated or too small when we apply it. So we can just play about with values. So we're going to call it UV scale. Normal, and we're just going to have a percent power of 0, and what we're going to do is connect that to the multiply here and the multiply here. After that, what we need to do is we need to apply a multiply, I believe. No, an add. So we're going to connect these two values together of the normal 1 and normal 2 texture samples, and then what we need is our normal, and then we can control our normal strength. So we're going to call it, we're going to create another scalar, call it normal strength, and then we need a flat normal, and then a, so we need our add to normal v3 and normal strength to flatness. And then afterwards, from the normal strength, no, flat normal, we connect it to our normal. So we're going to just drag that down slightly and connect it there. What's wrong? Forgot to assign. So for our normal 2, we need the same texture. So rock, just type in rock and detail rocky. And our UV scale will be 1 as our base value. And then we can play about and when we get into our instance material. Afterwards, what we can do is we create world displacement. So that's what we're going to do. Creating our comment. So just hold C and left click and you get a comment. Or you can just right click and you get new comment. So what we need is a vertex normal WS. Connect that. Then we need a multiply, and then another multiply, then finally a lerp. So we need the multiply to A and the second multiply to A of a lerp. Vertex normal will be connected to the A of a first multiply, and our scalar will be connected to our B, and the scalar is going to be called world displacement strength, or however you want to call it, as long as you know what it is, and it's going to be set to 5. Don't go any higher until you see it for yourself what it does. Then we need our, and then finally what we're going to do is just add tessellation multiplier. So our lerp here, so we're just going to make some tiny space because our tessellation multiplier is going to be just a scalar, but hey. So world displacement here, scalar, tessellation multiplier. And then our tessellation multiplier is going to be 9.452 and tessellation multiplier. So that is about everything, but there's more. As usual, we need to create our refraction, which is going to be, so it's going to create an effect. Obviously, what you can do is strip down every single one of those and you can see it for yourself, but I'm not going to be explaining it much. So what we're going to do is create refraction. And no, but no, this is world displacement. And then our refraction. So what we need is just call our comment refraction, expand out a small bit, and afterwards we call this refractivity. Yep. And this one is going to be called I just call it coverness because I actually have no idea what it actually is meant to do. If anyone knows, please tell me down in the comments, as that will be a much help for me. And then finally, a Fresnel. I think you can just hold F and you get a Fresnel. No, that's an unspecified function. So refractivity will be our base of 1, and our curviness will be 2.632. And what we need is a LERP, alpha our Fresnel, curviness to B, refractivity to A, and put into refraction. So, as you can tell, this is a lot of stuff to take in. But finally, what we're going to do is create something which will create something random. So we're going to just go over here, and this is why some of these parts are emptied out over here in our world displacement, because it'll be used for our random generation. So what we're going to do is we're going to create a comment called it. We're just going to call our wave features, because that's what it is. We're going to create random generated waves because it's using wave functions and noise. So to do this, we need absolute world position. So world. Yeah, so we need just a world position. It will be just called absolute world position, and then we need a mask. Nope, not that. Alpha mask. No, it was something called component mask. So the R for here, we're gonna duplicate, and we're gonna switch it from R to event to GB. So you have R and GB, we're all separated, and we're gonna connect that to that, and that to that. Then what we're gonna do is we need a panner. So get panner. Connect the GB mask to coordinate, and connect our multiply to our panner A. Multiply A with panner, and our wave speed, which is going to be our scalar, we're gonna call it wave speed. The scalar is just a constant parameter, if you haven't noticed yet. So yeah, that and that. And then to B. Then what we're going to do is we need a pen vector. So append vector, connect it there. Mask R to B, multiply to append A. So, what we're going to do now is we're going to apply our append vector to noise. So we're getting noise, and we connect it to position. What we can do is we can just get that part out, and what we can do is kind of see what it looks like. But what we're going to do now is change a few settings in our noise to, so our scale to 0.01, 0.11, then our levels to 6, so that's fine, and level scale to 2, yeah, everything's good. I'm just kind of checking because I've got every single screenshot on my phone, since there's a lot of stuff to remember. And finally, what we're going to do is we get our sine. So this is a bit of math. And afterwards, what we do is we apply to our B here, which afterwards in our world displacement, which also our alpha here is done. You can play about with inclusion if you know. This is the current features I've implemented so far. And what we're gonna do is we apply. So as you can tell, our War Master looks very weird, but don't let that discourage you. It's meant to look like that. So what we can do is get the final effect. So once this is saved, because if the engine crashes, we are in deep shit basically, because then you'll have to re-input everything all over again, and it's nasty. So what we can do now is close this down, and as you can see, this is what our war looks like. It looks like shit, basically. So what we're gonna do is apply our War Master, and we're gonna enable every single one of these. And so what we can do is then play about with values to get what our things right. So as you can tell, the normal is not moving at all. So do is get our scale a bit higher and our normal speed to something on the my bad. Our War Master requires one tiny alteration, because I forgot to mention. What I have to do is get every single speed X and Y. So we need our speed X here to 1, and our speed X here to 1 here. So so our speed Y here, speed X here, other way around, doesn't matter much. And same with our other panner here, because then it will be multiplying 15 by 0%. So we do that, get that to 1, and from what I can tell, we're in the clear. My bad. I forgot about that one part. So what we can see now is this weird effect, which, my bad, I did not mean to kind of do that, but what we can do is quickly change that back to its base value, and we get this more calmer look. What I have to do, we have to play about with our opacity, so we need to make it just right look. Obviously, this color cannot appear like that, so I don't have much control over it though. But what we can do is play about our normal, so we get rid of these kind of black, which looks very distasteful, if I say so myself. So our normal is our normal speed. Where is this? Where is it? Pretty sure I have it. Here, normal strength. I forgot to categorize a few things, so please categorize them whenever you can. And now we get is a little bit more nicer and less stronger war waves or textures. So about there. So this is about it. What I can cover. You can play about with values yourself to get a different result depending on what you're looking for. I'll sign up now. See you guys.